so
Yes, Mr.
much.
Mahesh. Okay, awesome. Yes, sure. So I'll jump into the agenda once. So I'll give a brief introduction of what AMRs are, and just talk a little bit about and shed some light on how AMRs work in general. That will talk about a little bit on the hardware side of things, how AMRs basically navigate and do their functions, and then we'll be talking about a particular part of or a particular component of how AMRs are handled using fleet management systems. And the reason why we'll be talking about this is because fleet. Uh, we depend on AWS when we deploy and we work with fleet management systems there. So AWS comes into the picture there, and Nipalin will take you through the implementation or the technical side of how FMCs or fleet management systems are deployed and run in an AWS environment and what all AWS services are there. And we'll just talk a little bit about the Continental mobile robots product offerings. So what kind of robots we are building and what kind of domains they get deployed in. And then the next three agendas about the AMR onboarding, about the OT updates and customer relationship management, Napoleon will take you through these topics. These are generally he'll be talking about the AWS architecture and how these are deployed on AWS. So basically, we are also trying to show you like how the journey is, and because AMR onboarding is talks about the scenario when a robot is deployed at a customer location for the first time. So when it's deployed at the first time, then what all the bootstrap things, what all the initial setup things it needs to go through, and how AWS comes into the picture there. And once it is deployed and it's functioning well there, right, and then it needs to be updated depending on the location, depending on the scenario, depending on the change in the map or in the site. So how these OT updates to the robot are done, again using some of the AWS services like IoT Core, API Gateway, Lambda, and things like that. And then once a robot is deployed there and functioning well, then how we handle also, like how we build the customer relationship management. So we have built an in-house portal there, and that is also deployed on AWS. And in the background, it talks to Microsoft Dynamics 365. So yeah, but the front end, which is facing to the customer, because again, this is very specific to the robotic use cases. So when a customer raises a case with us, they have to fill in certain fields. They have to attach certain log files called ROS bags and other things. So we have built an in-house customer relationship management tool, which is also deployed on AWS. So we'll be talking a bit about that too. Okay, the picture you see here is actually a Continental mobile robot. This is belonging to a variant called IL 1200. So, as just a generic definition, autonomous mobile robots are self-navigating robots that perform tasks with minimal human intervention. And how do they do that? They have some of these hardware sensors, like cameras, like lidars. So, and some other sensors fit around the robot, which helps a robot make its decision at a particular site. So, with these sensors, it gets to know where exactly at a particular map the robot is there, and uh, what is the next course of action, or what is the next step it has to take. So all these hardware components, they come into the picture. And yeah, so inside a particular robot there is we deploy something called an IPC. It's called an industrial PC. It's basically an Ubuntu system with a ROS operating system. It's called robotic operating system, and that has a lot of these software modules running to do with navigation, to do with perception, to do with localization, and things like that. So all these sensors and cameras and lidar feeds, they go in these feeds, they go into this IPC, and the software modules that they operate on these feeds, and then they make a decision of how a robot should operate next. Some of the applications where the robots are deployed are, you can see there is warehousing, agriculture, manufacturing, healthcare, retail. Basically, robotics in the current AMRs, in the current senses, are helping with industrial automation. As Continental mobile robots, we are into warehousing and agriculture space, which I'll be showing you those robots too in a while. Some numbers and figures, how this whole AMR domain is shaping up, and what the future looks like. So currently you can see that the global AMR market is projected to reach 3 point again, I think this is a little outdated data, so 3.88 billion by 24, and it's expected to hit 8.02 billion by 2029. So Samsung is one of the example who are heavily getting into industrial automation. So AMRs are being used everywhere. And then warehouse efficiency. So in logistics and warehouses, you can see that it can save up to your cost by 30%. So again, uh, especially in a warehouse environment, generally you would see a lot of human manual work going on while people are lifting and shifting stuff and things like that. So what could be done by a few human beings can be done by one robot there, though the initial setup takes a little while and there's a little bit of higher investment that side, but over a long period of time you would see that the robot is able a single robot is able to do the work what a couple of human beings are doing. One more point, like they enable dynamic material handling. So a lot of these materials, maybe it's to do with temperature or other shapes and sizes, which could be a little challenging for a human to lift, can be done little easily by a mobile robot. And the labor cost, the last points. So in developed countries now the labor cost is very high. So with that, the industry is shifting to autonomous mobile robots there again to save money in the long term, and also that the robots can work day in day out. So there is an advantage of robots there too. Okay. Again, on the picture, what you see is another Continental offering. This is also an IL 1200, but with a LiDAR. So if you see it here, you could see this particular rod is called a LiDAR, and there are cameras and other things fit to it. So this LiDAR can generate a 2D map or a 3D map, and that helps the robot. That 2D, 3D map can be analyzed, and that helps robot to make the next decision or to finish his next course of action. And the other cameras and sensors also fit around it. There are AI algorithms which are running inside the IPC, inside the robot, which helps in path planning and obstacle avoidance. And then there are the hardware parts about motors, controllers, the tires, and other uh, other steering things and everything like that, which control how the robot moves around the map. And there are quite a few navigation techniques. The one we are heavily dependent on is SLAM. This is stands for simultaneous localization and mapping. There are things like video odometry and then beacon-based navigation, but we are using SLAM in most of our use cases. And then there are these. So SLAM is basically it helps you dynamically change the path. So suppose there is a particular site or there is a particular map, and then today the robot is going from A to B, but tomorrow if it encounters a blocker in that same path, it can dynamically route itself without colliding or without causing any harm at the customer site. And then there are also pre-programmed paths which help robot in making some dynamic decisions. Yeah. A little bit light on what fleet management systems stand for. So again, fleet management system is it has just a little bit of history around it. So right now there are use cases where there are customers who have their warehouse sites or they have their warehouse sites and they are using AMRs or AGVs, automated guided vehicles, from different customers. So uh, the Germany Automotive Association thought there should be a particular standard where um, if a customer wants to use AMRs from different customers, then there should not be too much time and hassle put into integration of these different AMRs from different vendors, right? So basically, if I have an AMR A from one vendor, AMR B from different vendor, they should work seamlessly, and I should be able to assign tasks to them or give missions to them from one standard software solution or something like that. So that's where fleet management systems and the standard is called VDA 5050. So basically a fleet management system is a controlling place or a central controlling software where you can control different robots, you can assign missions and tasks to them. Using that, you can on the screen you can see okay how your robots are performing in a particular map or a site, and then that can also be used to avoid any collisions between the robots like that, and that will work for robots from different vendors. So that is at a very high level what a fleet management system does. And also I think this will also help you to track how the robots are performing, like their health matrices, to see if a robot is active or a robot has suddenly stopped or has broken down in between. So fleet management systems, they help you with all of those things. Again, this is again is a very general highlight of what constitutes the components of a fleet management system. This is a centralized software. It orchestrates tasks and monitor robots. Then it serves as a communication infrastructure between them. As I told you, there are use cases where a particular customer could be using AMRs from different vendors. So, in the absence of FMS uh, uh, compliant with VDA 5050 standards, in the absence of that, there would have been a middle layer or a middleware, like making sure the two AMRs from different vendors are talking to each other. But then, with the help of these FMCs, the communication between these two or the integration between these two becomes much simpler. Then again, it's very straightforward. It's a task management module where you can assign tasks to a robot. Fleet management system also has a map module embedded into it, so you can see how the robots are navigating around the map and how the traffic is being controlled, because at a particular map there could be a black zone where robots are not supposed to enter and things like that, and that could dynamically change maybe on a daily basis or a weekly basis. Today, if the robot is navigating around one area, tomorrow, because of some reason that could be a black zone. So those things you can control, or you can monitor using an FMS system and see that, okay, the robots are performing as they are supposed to. And then if a fleet management system also works, integrates very well with like something like a warehouse management system or an enterprise resource planning system and other IoT devices. So the reason why IoT devices are there is because with the help of AWS, we talk to robots as though they are IoT devices. So we use this AWS service called AWS IoT Core, and it has a lot of services inside it. And then using that, we talk to a robot as though it is like a proper IoT use case. And then, with OTA and everything like that. Okay. I'll just shed some light on these two product offerings, and then I'll hand it over to Napoleon for the next technical architecture and side of things. So we have currently we have two product offerings. One is in the intralogistics space. This is called IL 1200, and this robot can lift and shift a lot of things, like from a rack to a cart, to maybe other tires and everything like that in a particular automation plant or manufacturing plant. And yeah, just for example, these we have a customer called Harry Broad. They are one of the biggest bakers in Europe. So for their warehouses where they store bread, these robots are used where it lifts heavy and vertically long racks and places it in a block storage kind of space. The other one, what you see on the agriculture side, this is our agriculture offering, and these are used in greenhouses. So basically these are the foundational mobile robots, and you can attach any other device on top of it. I can talk about a customer use case. The customer is called Octiva, where they use our robots and they deploy it in greenhouses in Europe. So generally the greenhouses are taking shape in Europe, where you have a particular greenhouse with rows of plants in between them, and between every row you have like a railway track, like rails. So this robot can detect those rails and go in and out of it, and then change lanes and go everywhere. And other machine. So basically, I can talk about a use case where these are strawberry fields, where the strawberries are needed to be exposed to UV rays for them to not get infected. So these robots, they go over the rails, and there's like a UV exposure kind of a light on top of it, and then the strawberry plants are exposed to these. And these they can do day in day out. They can also, so sometimes the rails are rusted, or sometimes there is a dent or a gap in the rails, but the robots, they detect that, and they change their behavior dynamically depending on the use case, and they still perform. I think at this point I'll hand it over to Napoleon to take you through the other journey of onboarding, OT, and customer relationship management from here. Napoleon, all yours. Yeah.
Thanks, Anuj. Hello, everyone. I'll take you through some of the use cases where our solution has evolved and modernized by leveraging AWS technologies, such as for enabling seamless AMR onboarding and provisioning, and over-the-air updates, and remote troubleshooting, and the customer experience. Traditionally, if you look at it, our robots and software systems were not connected to the internet. Therefore, if there are any issues with robots, it will be a manual process to troubleshoot and time consuming. In partnership with AWS, we enabled our robots to onboard and provision into the cloud at scale. With these, we are able to manage our customer intralogistic and horticulture automation with ease, efficiently, and also adapting to the change request frequently. Um, to begin with, the AMR onboarding starts by flashing the IPC with AWS Greengrass setup. While Anuj was talking, he was referring some of the industrial PC. When AMR has been manufacturing at the manufacturer plant, the industrial PC where the operating system will be flashed into it. Along with that, we also set up the AWS Greengrass and the CLI, and we also build around AWS CLI some sort of scripts which will be interfacing to the AWS cloud for initiating the onboarding process. So once that is available, the operational engineer at manufacturing will be able to access the endpoint that is provided by API gateway, and with the credentials what we issue to them, and they'll be able to enter the robot data, and those data will be onboarded into the AWS IoT core, as Anuj was mentioning, as a IoT thing and as a Greengrass device. Now that the robot itself will be considered as an edge device as a Greengrass. So the communication to the cloud is established securely using the client certificate that the AWS IoT platform issues to the robot. Next slide, please, Anuj. Yeah, this is an architectural diagram explains how multiple applications and AMR systems are connected in the cloud. Our solution supports both cloud-based and the hybrid model. What you see on the right side is a hybrid, and the left side is the cloud-based solution. As we are speaking, the AMR journey begins with by onboarding into the centralized cloud application what we have. The centralized cloud application will be there in the corporate continental AWS account, where that will be managing one or many robots while it is in manufacturing. Once it is manufactured and the customer journey begins, when the customer journey begins, the customers are signing the contract with the Continental Sales. Once that is done, the customer data also onboarded directly into the centralized cloud application. That's what you see on the left side on the cloud-based application, Continental application. So that's where customers and AMRs are come together in the centralized cloud platform. So when a customers are buying one or many robots, those robots will be associated to the customers. We also enhance the solution by providing customer portal. So when these particular robots are handed over to the end user, the end user get to access a customer portal where they'll be able to see their set of AMRs and FMC. So FMC, as Anuj was mentioning, like it is specifically used to monitor and control the fleet of AMRs. So if a customer also availing the FMC use cases, FMC application, so that has two sides of it. I'll explain that. And the FMC and AMRs will be associated to the customer, so that when the customer is directly logging into their customer portal from the customer provided AWS account, they'll be able to see the AMRs and it is available feature. And the AMRs are connected to the AWS using on-demand internet connection. If you see in real time, the robots are placed in a warehouse or greenhouse in the remote regions where you don't get to connect to the internet. The hybrid model helps the AMR as well as the FMC work offline seamlessly with the Greengrass setup, where FMC and AMR fleet connected through the MQTT broker, what we call it MQTT broker, that exchanges communication between one or many AMRs as well as to the warehouse management system, as FMC also connected to warehouse management system, building management system, and other warehouse applications that is the customer is using it. So all of them are connected and communicated through the MQTT protocol protocol. Communication among AMRs are using the standards protocol. As Anuj was mentioning, we use VDA 5050, and robots also will be supported with mass robotics when we move to other region. So with this setup, like the hybrid model in an offline works seamlessly, and when there is any updates or when there are other feature which I'll be discussing in the next slide, on need basis will be pushed to the customer portal as well as to the manufacturer portal. So the manufacturer or the customer can decide to push those updates or push those like system configuration, software configuration. Could be the AMR brain needs an upgradation. So all those can be decided by the manufacturer or the customer, and these work seamlessly with the AWS IoT core platform as well as the Greengrass setup that we have it as an edge platform. Next slide, Anuj. Yeah, as I was saying, like the software updates are one of the core requirement and feature for the AMR, which needs like a periodical improvement. Especially this is used in the phase of initial product development. If you look at it, the manufacturing plant and what do you call where the robots are being developed in a region where you don't get internet connectivity. So the software flashing and the brain software which has to be flashed to the robot which is there, which can happen from a different region. So here you see the time latency, all those things. So now that we have onboarded AMR and provision into the cloud, and we have the cool feature and capability from AWS called secure tunneling. Through secure tunneling, like we'll be able to do remote troubleshooting and remote deployment on need basis while it is manufacturing itself, so that we ensure the quality checks and factory test and the test performed for the AMRs with other lidars and hardware components, cameras, all sensors, whatever that attached to the robot is working perfectly. All those things are done through two aspects, like we do a continuous remote deployment through the secure tunneling, and also like we use the OTA updates. I'll explain in the next slide in detail. Next slide, Anuj. Yeah. This is the architecture that talks about, explains the complete life cycle about over-the-air update with respect to system configurations or software components and packages that are very much required for the AMR fleet. This begins with our DevSecOps team, where they'll be able to automate. They have already automated when there are any feature or software component that are developed within the corporate code repository that is packaged as a container image and pushed to Amazon easier automatically. Along with that, the container image may also require some sort of artifacts or binaries or packages that needed as a configuration dependency. Those are pushed to S3, and this setup through the pipeline automatically replicating to the corporate AWS account as well as the customer AWS account. And along the way, the particular container image also created as a Greengrass revision. Inside the Greengrass, every components creates as a new set of revisions, and that set will be available to the customer portal, and so on. Like the feature is ready with next version, all those things as a OTA as well as the system configuration, everything will be displayed to the end customer, so that it is their responsibility and they have the freedom to act on that particular updates, so they can pick those OTA and automatically send those updates. So the AWS IoT Greengrass automatically pushes those updates to the Greengrass nucleus configuration that we set up in the AMR as well as any edge platform. In the other case, like FMC also set up as an edge in the hybrid model within the warehouse workstation or a greenhouse workstation. So if there are any updates required to the FMC, so the updates are taken through the IoT Greengrass, and the updates are very seamless, and we are able to upgrade the system, upgrade the AMR fleet on the need basis. Next slide, Anuj. Yeah, some of the benefits and best practices by enabling this AWS partnership to onboard AMR into the cloud, and we were able to manage like fleet provisioning of one or many AMR automatically, and as I was saying, like we were able to do updates in quickly. And the other nice feature which I would like to mention here is like within the hybrid model, where you see the entire setup works like you are in the cloud, you are in on the AWS account. You don't get to see your system is offline. So which means you are able to connect to the and exchange communication to AWS IoT things which are pointing to another set of AMR, as well as we are able to integrate with AWS Lambda to do the business logic, and other like features are included. And the other one thing that the communications are very secure between data encryption and like device communications. Maybe next slide. Due to time constraint, I can rush it. Yeah. This is the last thing that uh, we developed a customer portal as an in-house project, in-house application, as Anuj was saying in the beginning. When AMRs go live, we wanted our customers to raise their incidents and track and trace their statuses. And if any incident requires additional set of information for troubleshooting, like we have ROS backs and photos and videos, if there are robot breakdown and performance issues or something related to FMC, all those things the customer can directly upload here. And this is by leveraging AWS serverless architecture, we provide this end-to-end solution by integrating with the customer relationship management tool called Microsoft Dynamics. So we do the data sync on the need basis, and the customers are updated up to date. So they need not to wait for the sales to push the requirement or push the updates to them, and until they're blocked like that. So with this, like we have significantly improved the customer experience. Anuj, maybe the last slide. Yeah. Yeah. um so this is one of the great advantage and benefits, I would say, by adapting to serverless architecture of AWS, and as well as the entire serverless implement we have done through AWS PDK framework, and it uses Progen. It ensures the customer like us, where you only focus on business, and you don't worry about infrastructure and infrastructure provisioning. AWS CDK provisions the entire infrastructure for us, through which like the entire development was simplified, and we improved in the productivity, as well as the entire communication within the serverless resources are very secure, and only authorized access allowed to the AWS resources. And by design, and the AWS serverless architecture is scalable and fault tolerant, where we no need to write the logic of doing error handling and retry mechanisms. So all those are all inbuilt, so that this particular environment is available to the multiple customers automatically, and they ensure us. So we focus on adding up the customers. So we don't focus on high availability and scalability. It's taken care by default. And the last thing, AWS pay as you go model has substantially improved our cost savings as well, because in this kind of scenario where you only like use or raise incidents for the customer relationships on the need basis. So we don't utilize the AWS resources unnecessarily. So for what have we used, and that's where like we are paying it, which through that like it has like helped us a lot. Um, yeah. With that, I conclude the presentation. Look forward to your questions. Yeah.